Hi, and welcome back. And we've got the second session now, and this session's on millimeter wave. And I'm sure, like a lot of other people, I've been fascinated over the last couple of years by the rapid increase in focus on higher spectrum bands, both for fixed wireless access, for Wi-Fi, and also for 5G as well. And there's a lot of discussion about which bands, licensed and unlicensed use cases, whether it's fixed, mobile. And what we're going to have now is a presenter, Antony Holmes, who's the VP of millimeter wave products from Cambium, who's going to be talking us through what the company is doing. So with that, I'd like to move over to Antony.
Hello there, my name is Antony Holmes. I'm the Vice President of Millimeter Products here at Cambium Networks. Over the past 6 months, there has been a dramatic increase in the awareness of fixed wireless, connecting the unconnected being even more important to everyone, driven by a confluence of factors, including the escalating demand for broadband due to the COVID pandemic and the anticipation of 5G fixed wireless access as an alternative to fibre. There is another reason for the excitement in the world of fixed wireless: the arrival of the new 802.11 standard and Terragraph as platforms become available for multi-gigabit fixed wireless solutions. The timing couldn't be more perfect for these game-changing technologies. With this technology, it is now possible to deliver reliable multi-gigabit wireless broadband at the edge of the network. With dramatically lower costs and time to deploy, the possibility is nearly endless. Over the next 20 minutes, I will give a brief overview of the technology and the architectures that make this possible. I will focus the majority of the time on how the 60 GHz solutions can be and are being applied in real-world use cases that all of you face every day. Current view of fixed wireless are radios on tall towers in locations where wireless broadband is not viable, beaming down to the areas below. Now, we're bringing fixed wireless down to earth, literally. Distributing the wireless backhaul from point to point, expanding out and spreading across areas we wish to cover. With millimeter technology, the propagation does mean that you have shorter ranges than traditional fixed wireless. But with beamforming and physical size being so much smaller, these radios can be strung together, lower to the ground, using the side of buildings, rooftops, street lamps, to get the coverage and density that you need. You don't need tower climbs for these solutions, a cherry picker, a ladder. These will come in handy. But physically deploying 60 GHz solution should be no more different or difficult than a physical deployment of Wi-Fi APs, making this solution so much more accessible to enterprise and non-telecommunication operators. So what's changed? 60 GHz has been around for many years, whether WiGig or 11AD. 11AD has been available for 10 years now. This offers you high throughput, short range, but that's it. It's limited really for PMP and high density deployments. The 11AY standard changed that. Qualcomm and Facebook technology introduced many changes along with the .11AY standard. For example, network capability and capacity. You have the same 2.16 gig channels, but now you're capable of transporting 3.6 gigabits per second in each channel. Channel bonding has the potential of even doubling that rate. With the improvements to the MAC and PHY layers, software-defined radios, you can get fiber-like performance with this wireless technology. Scalability, lower total cost of ownership. These radios are affordable. It means you can get more of these, you can use these, distribute these, expand these, increase your network coverage and capacity. Lower deployment times means it's easier to deploy. You don't need to have expensive tower climbs. Basically, with beamforming as well and centralized management controls, it's simpler to deploy. The amount of training and expertise you need to put these up is lower. Dense deployments. Network synced TDD frames allow more units to work together and share a single channel. Interference mitigation. Beamforming helps here, but there are other methods as well in order to pack in those radios and get that capacity your network needs and your customers demand. Network efficiency. Multiple points of presence, POPs, allow capacity to be shared across your network. Multiple ingress points to your network optimized for load balancing and rerouting of traffic. Coordinated scheduling as well allows quality of service. High availability. Mesh networking and traffic rerouting and self-healing itself. And on top of all this, cloud management, zero-touch installs, scalability, high availability, allowing you to control hundreds, if not thousands of units in not one, but many networks. All this together gives you endless possibilities for the type of deployments that you can deploy this in. Small cell backhaul, campus area networks, fiber extensions, urban or rural networks, enterprise, anywhere that demands gigabit rates, you can use this technology to provide it. Now, standards are great, but that's just what they are, standards. They enable us wireless experts to build solutions that are easy to plan, to deploy, and manage. Solutions that just work. So, how do we turn these possibilities into reality? It starts with the radio technology from our partners like Qualcomm, technology based on the 11AY standard. There are enormous capabilities built into these chips that we can leverage because of the APIs, and we can tailor these to the demands of the different verticals and markets. Not all wireless devices are the same, even if they use the same technology, and that's because we use software to make the same radio, the same technology and chips to be optimized for different jobs. This is the software-defined radio. Distribution node, for example. This is where you want that radio, you want to be able to string that along the streets, connecting many clients along the way, backhauling information. Yet you want different clients to provide different ranges of throughputs. Not one platform serves all your needs. In addition to point-to-point, 60 gigahertz can be used in point-to-multipoint. The real breakthrough is the mesh technology that Facebook has developed in partnership with Qualcomm, ourselves, and others. This gives us high availability and scalability. Whilst you may not be climbing towers, you still want to know, and you need to know, how many, where, and what to deploy, and what performance to expect from your radio and your network. This means building network designs that accurately predict the performance and reliability before you even start, before a truck is rolled. Because 60 gigahertz is part of the fixed wireless ecosystem, these tools can be used for all types of fixed wireless deployments. LiDAR-based tools give you accuracy for line of sight, non-line of sight, down to meters. Proven fixed wireless link planning tools enable you to be able to plan your links and know what the throughput and capability of each one of those links are well in advance. Advanced mesh planning tools allow you to understand how to get your high availability and how to get your reliability. And then you have beamforming. The automatic beamforming enables you for ease of installation. You're able to come along there, the radios will beamform together bidirectional and optimize the performance of that link. Of course, layered on top is a mature network management software platform. You can manage the wireless solution from the backhaul. You can the fixed access right into the home or office for a single management system. Again, while it's a new frequency, the same management concepts apply, which is why we can bring this new technology into these new use cases with proven management systems. So let's go through a few examples. City centre, for example. Gigabit wireless across your city centre. Point to point, you can have rooftop to rooftop connecting buildings, offices, or extending fiber point of presence from one point to the next. Next, mesh at root level. You can mesh multiple customers, multiple businesses, providing backhauling capability and internet access to each one of those. You can then go down to street level, from lamppost to lamppost, again, stringing units together in order to provide backhaul and access. Each one of these can have on there a Wi-Fi device to offer customers and consumers Wi-Fi access, or camera backhaul. Security cameras can be on here. So let's look at some real life examples. Here we have a Wi-Fi backhaul network in North America. Here we have a usual grid-based system of radios, and each one of these has a Wi-Fi device attached to it to offer customers and consumers a Wi-Fi access. In addition to this, we also have business clients who are demanding high throughput and data rates for their business needs. In this, you can see this is being planned through a link planner, and you can see how they all string together, and you're able to plan how many distribution nodes you might need, where those distribution nodes might be, and the performance that each one of these customers might get. The red teardrops are potential future clients. You don't have to put in the radios to cover these yet, because the technology allows you to expand that network in the future to cover those areas as and when you bring those clients on board. You only need to spend and deploy radios where and when you need them. Here's one of the largest 60 gigahertz networks currently in existence. We are working with YTL in Malaysia to replace the old technology with the new upcoming CM Wave 60 gigahertz technology. This is around about 400 radios throughout the city used to provide broadband services to both residential and enterprise customers. Again, it's also used to backhaul Wi-Fi, offering everyone in the city access to Wi-Fi, free Wi-Fi and public Wi-Fi. Now looking at residential broadband. Residential broadband, this can be from a small community like this, just linking just a few houses together, or can be many streets. The network could grow from 4 to 400. Basically, you can provide gigabit wireless backhaul and gigabit performance to each one of these houses. Let's look at some examples. Here we have in North America a rural application where they need to provide and show that gigabit rates can be given to each one of these customers. What we have here is a plan where you can expand out to small areas, clusters, and deliver that kind of capacity. As you can see here, we've got an uplink and a downlink running around about 1.8 gigabits per second to this customer premises. Looking at enterprise, we have an industrial estate here where we have a fiber point of presence comes in. It needs to be distributed around this enterprise industrial estate. Now, instead of digging up these car parks, instead of digging up the sidewalks, we're able to use distribution nodes from building to building and link each one of those to the fiber point of presence. Even along with this, we're able to provide Wi-Fi access, again, to public areas. Campus connectivity, whether it's a hotel complex or a conference center or a university college campus, a private network where you want to actually provide not only backhauling from building to building, but Wi-Fi coverage as well. This technology allows you to get gigabit rates around that campus area. Industrial applications. For an example here, we have a rail yard. There's a lot of metal in here. There's a lot of moving objects. It's a very harsh environment. You need a rugged, reliable radio system, not only physically, but also as far as the radio is concerned as well. By using mesh, you're able to have a way of self-healing and backhauling data. If there's any moving objects or if there's obstacles get in the way, you're able to reroute quickly and still give that connectivity. Industrial IoT. Here we have a large industrial plant. What we want to provide here is not only backhauling information from factory to factory or office to office, and this can be data for users using computers, or it actually could be IoT from machine to machine. This system allows you to backhaul that data around, as well as offering that the Wi-Fi devices on each of these allow the office workers and the people around the site to walk around and have connectivity at all times. 5G, small cell backhaul. A lot of people have been talking about this for many years. Now we're at the brink of being able to provide it using the 802.11ay technology. While 5G can be used to do this, those frequencies are a valuable asset. In these deployments, you can use 60 gigahertz instead to provide a multi-gigabit backhaul to these cell sites, while they get on and do the mobile backhauling. We are able to provide point-to-point access and extend the POPs, or the points of presence range, and then using point-to-multipoint provide small cells the access they need and the data backhauling they need. Even in built-up areas like a city centre, you can turn non-line of sight to line of sight using DNs and client nodes. Stringing DNs together, you can go around obstacles, and alternative paths can be created to increase capacity and availability. As these radios are synchronized, unlike Wi-Fi, where the more APs you have, the more interference you get, this technology has interference suppression and methods in order to have that high density, high capacity that you need to be able to group lots of these radios together. In the old days, capacity like this would require fiber to get that gigabit rates. Now you can look at using wireless to extend the reach instead of fiber. Here's an example of a small cell backhaul that we're working on. We have 3 small cells here in a city street. You need to be able to backhaul from all 3 of those. So instead of putting a fiber between each one of these points, you can use a high availability, highly reliable 60 gigahertz link to be able to connect these at very high data rates. The demand here is for 5 nines capability and reliability. The 60 gig technology enables us to link these together at gigabit rates with 5 nines capability. This technology has many applications and verticals where it can be utilized, whether it's urban, residential, or rural service providers. Low-cost client nodes meet various ranges and performance challenges. But further to this, there are many examples where a radio like this helps with campuses, office sites, industrial applications, and even to expand coverage of fiber and provide that wireless fiber capability. Now with that, I'm going to show you a short video.
"60 gigahertz CN wave. Wireless is the new fiber." People need affordable broadband connectivity wherever they are. But how can a service provider rapidly deliver reliable multi-gigabit connectivity at affordable prices in locations where fiber technology is cost prohibitive? And how do you provide coverage exactly where it's needed while containing costs? Deliver multi-gigabit wireless speeds without all the hassle of trenching fiber with 60 gigahertz CN wave solutions. Now you can build a multi-gigabit wireless fabric from network infrastructure to last mile access. With our 60 gigahertz CN wave solutions, service providers rapidly connect people with better connectivity wherever they are. Enterprises easily and efficiently manage a private network tailored to the business. Utilities expand service offerings to include broadband. Customize CN wave to tailor the network to meet coverage and capacity needs. Point-to-point bridges between locations. Point-to-multipoint distribution networks. Highly efficient mesh networks to provide blanket coverage around obstacles. Leveraging the 802.11ay standard, 60 gigahertz CN wave delivers reliable high-speed connectivity at a low total cost. 60 gigahertz CN wave system components include the V5000 distribution nodes that support 2 coverage sectors up to 30 clients in a 280-degree arc with a single module. Client node options include the V3000 high gain module and the V1000 mid gain module. Plan the deployment with our Link Planner and CN Heat software tools. Manage the solution and the wireless infrastructure with end-to-end visibility in the CN Maestro management system. Network operators choose Cambium solutions for high reliability, cloud management with the CN Maestro system, and low total cost of ownership. Operators can deploy wireless broadband and indoor and outdoor Wi-Fi networks with confidence that they will work, even in demanding environments. Deploy fiber-like speeds now without trenching cables. 60 gigahertz CN wave solutions from Cambium Networks make it easy to deliver and manage edge connectivity and connect people, places, and things wherever they are. Wireless is the new fiber. Start building your solution today. Contact Cambium Networks.
So I'd like to thank you for listening, and if there's any questions, please feel free to ask them.
Antony, thanks for that presentation. Found myself on that last video segment trying to guess or recognize all the cities that came up in there. And first off, I'd like to ask the audience, you'll see the Q&A box underneath the video panel on the website. And also, before we get on to the questions, I'd quite like to push a poll out about 60 gigahertz applications. So you should see that come up on your screen with what applications the audience expects for 60 gig, whether that's backhaul for Wi-Fi and small cell, campus networks, fixed wireless access for business or residential, multi-dwelling units or something else. And while people are answering the poll, Antony, got a few questions. I mean, actually, I mean, so at least one of the cities I recognise there was Copenhagen, and I don't know whether that's where you have deployment, but certainly in markets such as could be Northern Europe or a number of in Asia, rain, snow, other weather factors start to come in. How does that impact 60 gig?
It doesn't just impact 60 gig. Rain will impact most millimeter wave products. What you have to do is plan for it, and this is where you utilize tools like the link planner to help you do that. Work out what excess path loss you need for the availability that you want. So with rain, you would actually don't plan for no rain unless the availability you can live with. Tools use IUT standards. We actually can use predictions down to just tens of meters using statistical data. So I would advise that you plan for path loss, you plan for rain, and with that, and with modulation modes, with the way that the standards work and the PHY works, you can actually get very robust links at 60 gigahertz.
So presumably that's the same for line of sight issues as well.
Line of sight's slightly different. I mean, this is the exciting thing that we've got with the AY standard and these distribution nodes. In the past, with AD, yes, you could have multi-point, but there were issues with dense deployment interference. With the way that you can string distribution nodes together, you can actually turn non-line of sight into line of sight by having multiple units go around obstacles. And again, we would advise using latest planning tools, CN Heat, or there are other tools you can have. You can actually, with the LiDAR data, see where clutter is, obstacles are, and with the meshing, you can actually, as I say, turn non-line of sight into line of sight.
Good stuff. Okay, let's have a quick look at the poll results. So we're a little bit short on time on this Q&A session, so if I get time, there's a few good questions that are cropped up. If not, we'll come back to those in the panel session at the end. But in terms of that's a clear win for Wi-Fi or small cell backhaul, which is definitely an interesting one there. And then fixed wireless for either B2B or B2C. Does that surprise you, or is that what you expected?
Not really. Actually, the small cell backhaul for many, many years, people have been saying how to utilize. But we're actually seeing with the technology now, it's far greater than just backhaul. The Wi-Fi, that's where the mesh comes in. You saw with YTL, the city deployment, 400 plus radios, with a Wi-Fi attached to about 100 of those distribution centers offering free Wi-Fi to the whole city.
So it's sort of multifunctional there. It's sort of Wi-Fi and small cell. A very quick one. I'm doing a lot of work on Open RAN at the moment with and there's a lot of discussion around front haul as well as back haul in mobile networks. Is 60 gig candidate for that, or is that some way down the line?
Okay, that's an interesting one. Front haul, I think it's about the latency between the BBU or RRH is going to be a challenge. You want to be keeping that down to less than microseconds.
Yeah, microseconds definitely start cropping up in conversations there. Okay, I think we've got time for one last quick question before we have to sort of wrap for this. There's a question here about sort of Terragraph and sort of what's the significance of Terragraph compliance?
Terragraph compliance is really the ability to not just for service providers to have an opportunity to use multiple different vendor hardware. This is like the Wi-Fi Alliance, where you can have different CPEs, different Wi-Fi devices in your network. You can utilize different Terragraph compliant products in your network from different companies.
Excellent. Okay, so there are a couple of other questions, but we'll hope to come back to those in the executive panel. So with that, Anthony, I'd like to thank you very much for that session. And for attendees, the next session will begin at 25 past the hour. You'll have to click the watch presentation, the next link in the video box below where we are now on the screen. And that will be Vivek, who's going to be talking about the coexistence of Wi-Fi 6 and 5G, which is a hot topic I end up talking about an awful lot. Anyway, Anthony, once again, thank you very much.
Mm-hmm.